to look at solving absolute value inequalities. So that would be something like this. I'll just give you a quick example because I know when I say absolute value inequality, maybe that seems a little strange. It would be something like this. The absolute value of x plus 6 is greater than 7. So we want to look at how to solve this. So let's back up just a second and get some notes down. So the first thing would be this. You can either write this down or just make sure you understand it. An absolute value inequality. So absolute value, we'll just say IQ. That actually turns into a compound inequality. Okay, so we'll just say IQ. So if you have an absolute value inequality, that's the same thing, or it gets made into a compound inequality. And if you remember, a compound inequality has two types. It has an and or an or type of inequality, which I've uploaded a video about that. So just make sure to check that out if you haven't already done so. All right. So just in a basic knowledge or basic understanding, if you see an absolute value inequality, you use compound inequalities to solve it. Okay. And you can have two types, an and an or. All right. So now your question, let's get rid of this. Your question is hopefully, well, how do I know if it's an and or if it's an or? So let's go through that. All right, so let's say I have, well, we can do this example again. We'll say absolute value of x plus 6 greater than 7. All right, so here's what tells you if it's an and or if it's an or. So we'll just say and or, okay? Now, the inequality symbol tells you if it's an and or if it's an or, and I'll give you a way to memorize it. So let's just rewrite this whole problem again, and now I'll make it less than. All right, so let's start with greater than. So if you're trying to find a good way to remember greater than, here's how I do it. And I've seen this a lot of different places. It's pretty good. So you say greater, but instead of saying great ER, you emphasize the OR. So greater means that it's an or inequality. Okay, so like in this top example, I can just tell you without doing any other work, since this is a greater than symbol, there's more to it than that, but we'll talk about that in a second. But just in simple terms, since there's a greater than symbol, greater means or. So greater is an or inequality. So I would set up an or inequality to try to solve this one. Now, same thing is true for the symbol of this inequality. It's actually giving away what type of inequality it is. So once again, let me give you another way to memorize it. So that's a less than symbol. Now, at the end of less than, we can emphasize the an part and then add our own little d at the end, and that gives away, or it's a way to memorize, that a less than symbol means it's an and inequality. So this one right here, this second example, if I have a less than sign, well, that's going to tell me that this is an and. All right, so then you can set up both of your inequalities by knowing that. Now, there's more steps than that, but just in a general sense, that's how you tell the difference between an or inequality and an and inequality. Now, let's go over one more thing, and then we'll be ready to do some examples. So here are the steps to solving an absolute value inequality. The first thing you have to do is isolate the absolute value. So you have to isolate your absolute value expression. So isolate the absolute value. Then you're going to make your two cases, and I'll show you how to do that. The best way to memorize this part is you can use something called the KISS method. Okay? The KISS method just means keep. We'll say keep it, switch, switch. keep it switch. Maybe I'm running off the screen a little bit, but that's okay. All right, then the third thing is solve. So you solve each inequality. So if you remember, this is similar to the steps for an absolute value equation. So the good thing is, if you know how to do an absolute value equation, you've already seen these 3 steps before. The only thing that really changes is step 2. Since it's an inequality, we have to do something very special with the inequality symbol. But let's go ahead and dive into an example so we can actually get an understanding. So I'm going to start you off with one that we've already seen. Absolute value of x plus 6 greater than 7. All right, so now our first job is to isolate. So once again, step 1, isolate. Now, you'll notice that when I do this, I'm not going to determine if it's an or an and until I do this part. So make sure you make yourself a note that says, first, no matter what, I have to isolate. Okay, so is my absolute value inequality isolated on this left side? Yeah, because there's nothing else outside of these absolute value signs on the left. So now that that's done, now I can figure out if this is an or if it's an and. And once again, look at your inequality symbol to help you figure that out. This is a greater than symbol. So once again, emphasize the end as greater, and that tells you that we're going to use an and, an or compound inequality to solve this. Now, this is where we do the KISS method. Okay, so we're going to set up 2 cases. Now, in between our 2 cases, we're going to have an or. Here's the first case. So for the first case, you're just going to keep what's in this absolute value. So you're going to keep this expression or this inequality the exact same, but get rid of the absolute value signs. So there's our first case. So this is case 1 right here. Case 2 is where we actually do the same process, but now we're going to keep the inside, x plus 6, but now this is where the switch part happens. We're going to switch our inequality symbol and flip it to less than. We're going to switch the sign of 7 to minus 7 or negative 7. So once again, here's what we do. For our 2 cases with an or inequality, so greater than symbol means or, we take the first equation or the first inequality and we just pretty much take out the absolute value signs. Okay, so we take the whole first part, we just say x plus 6, take out the absolute value, greater than stays the same, 7 stays the same. The second case, we're still going to keep the inside of the absolute value, but then we're going to switch our inequality to less than, switch 7 to negative 7. And then we're going to solve each of these. So hopefully this is the easiest part. If we want to solve case 1, we would say, okay, minus 6, so that we can do, get rid of that plus 6 and do the inverse operation. X is greater than 7 minus 6, which is 1. Or if we work the second case, subtract 6, x is less than negative 13. So I typically, if I were giving a multiple choice test, I would probably have these answers written from least to greatest like this. But honestly, the order isn't really that big of a deal. All right, but I'm just going to put my answer like that because that's typically how I would do it on a test, so I'm assuming most other teachers would too. All right, so all we had to do, once we break down or once we split this up into 2 separate inequalities, we're pretty much ready to go as far as solving. The biggest step, though, is to make sure you isolate first, then make sure you correctly set up your 2 cases. So let's do another one that's an or, and let's see if we can do that one. Let's find one where it's not already isolated for us, just in case we see that in the future. So let's do this one. This one looks like it's okay. So we're going to say absolute value x minus 1 all over 4 greater than or equal to 2. Now, our first step, once again, is to isolate. And notice, I am not even looking at the inequality symbol yet because it does not make a difference yet whether this is greater than or less than, because the first thing I have to do is isolate. So is my inequality on the left side by itself, is it isolated? No. We have divided by 4 on the same side, so we need to get rid of that division by 4 by doing the opposite, which would be multiplying by 4. Now, since we're multiplying by a positive 4, my inequality symbol is not going to flip. So it's going to stay greater than or equal to. 2 times 4 gives me 8. Now that my absolute value is isolated, now I can determine if this is or if it's an and inequality. So see if you remember, if I have greater, what's that mean? Does that mean or and? It means or. So we're going to make this an or inequality, and we're going to use the KISS method to set that up. So once again, the KISS method basically means keep what's on the inside of your inequality for the first case, and then you actually want to keep your symbol the same and the sign in front of your number on the right the exact same. Okay, now this part is going to change for my second case. This greater than or equal to 8 is going to change. We're still going to keep what's inside of the absolute value, but then we're going to do the SS part, which is the switch. So this switches and this switches. So instead of less than or greater than or equal to, it becomes less than or equal to. Instead of 8, it becomes -8. Now, I'm going to rewrite all this just so I can make it at least fit. But once again, isolate first, isolate the absolute value, then use the inequality to tell you if it's an or or an and then when you're setting up an or, make sure that on your second case you're flipping the inequality and flipping the sign of whatever you have on the right. All right, so now let's solve each. So x, what do we say? X minus 1 greater than or equal to 8, or x minus 1 less than or equal to -8. So now let's solve each of these. For the first case, we're going to add 1, x is greater than or equal to 9. Or add 1, x is less than or equal to -7. And once again, typically, if this is a multiple choice test for me, I put these in order from least to greatest. So we would say x is less than or equal to -7, x greater than or equal to 9. All right, so hopefully you're noticing that the solving at the end is not really the hard part. The difficult part's determining if it's an or an and. So now let's go to and, because we haven't talked about that yet. And let's do another one that is not isolated, just so we can look. And I'll show you one last example, and then I will be out of your hair. All right, so 8x plus 10 less than, or no, plus 3 less than 25. Okay, so our job is to determine, is this an or an and, but first we want to isolate, because it does not matter right now, since this absolute value sign is not isolated, it does not matter what this sign is, what this symbol is. The first thing I want to do is subtract 3 and get rid of this 3 to isolate my absolute value. Okay, so absolute value of 8x plus 10 less than 22. Now I can figure out, what does less than mean? Does that mean I have an or inequality or an and inequality? It's an and inequality. Once again, you can say less than and emphasize the and. I know it's a little childish, but it works. So let me show you how to set up an and inequality. There's 2 ways you can do it. I'll show you the first way, which is probably the easiest to understand. You take everything except for the absolute value, and you just use that same KISS method. So you can say 8x plus 10 less than 22. Then you can just write a big and in the middle. And then you can do the exact same thing we did for or. You can say 8x plus 10. You're going to flip or switch, and so this will be the SS part of our KISS method. We'll switch this to greater than, switch the sign of 22 to negative 22. And then we can just solve each. Okay, that's one way you could see this done. Let me show you the other way that you can do it, and this is personally how I like to do it. Okay, so what you can do is you can write this as a compound inequality that's all written together. So first take out 8x plus 10, and then bring down your symbol less than 22. Okay, so everything like that's worked the exact same way. Now, you can actually do this, and it will flip your inequality symbol. You can take this less than sign, but write it on the left. Then you can take 22 and make it negative 22 on the left. Now, if you notice, when we've done compound inequalities before, some of our inequalities were given to us like this. So you can actually make your own. All right, now, nobody's really going to care which way you do it. I'll probably do it this way because personally I like it. But once again, it doesn't matter which way you do it. So let's go back and let's rewrite it one more time just so you can see it. 8x plus 10. We've already isolated the absolute value, less than 22. So here's what I can do to set up my and inequality. I can take the middle. I can just take 8x plus 10, put that in the middle. And then I'm going to bring down everything just like it looks, just getting rid of the absolute value. Now, I can take this symbol and I can put it and almost copy and paste it to the left, because by putting it on the left, technically I'm flipping it. And then I can take 22 and make it negative 22 and put that on the left. So now let's look at solving this. Because essentially, I want to get x in the middle of my inequality symbols. So I'm going to try to move this 8 to the left and the right, and plus 10 to the left and to the right. Remember, you want to push everything from the middle to the left and to the right. So now, first we want to take care of this 10, so we're going to subtract 10, but I have to do it to the left and to the right. So now I'm going to end up with negative 32 less than 8x less than 12. All right. Now, the last step is we want to divide to get rid of 8 and get x by itself. So we're going to do that on the left, and we're going to do that on the right. All right, so now I'm going to be left with negative 32 over 8, which I'll just do this part over here, which is going to give me negative 4 less than x less than. Now, 12 over 8 would reduce down to 3 over 2. So there's my answer. I would say, okay, x is, well, I can do it from the left to the right. Negative 4 is less than x less than 3 over 2. All right, let's do another one just so you can get an idea of how this one works. And then I'll show you one last example, and then we're ready to go. All right, let's do one more. Actually, let's do, let me find a good example. We can do one that's already isolated just to make things quick. All right, so let's say I have absolute value 2v minus 3 less than 19. All right, so once again, isolate first. So isolate the absolute value first. It's already isolated. So now look at your symbol, and we're going to do the KISS method to set up our steps. So this is less than. So does that mean and, or does it mean or? It means and. So watch how quick I can set up this inequality. If I take the middle, I pretty much am going to take this entire thing and just remove the absolute values. Then instead of putting an and in the middle, here's what I can do. I can take this symbol, put it on the left, just copy and paste it over there. Take 19, copy and paste it, but make it negative on the left. And now I can just solve this. So I can say plus 3 plus 3. Have to do it to all sides. Negative, that'd be what? Negative 16 less than 2v less than 21. No, that'd be 22. I'm crazy. All right, so now the last step, we just want to divide in the middle. Divide by 2, divide by 2, divide by 2. So then negative 8 less than v less than 11. And that would be our answer. All right, now, hopefully at some point you've thought, why is this dude making such a big deal about isolating? So this is the example I want to show you for that. So I won't draw this out too much longer. Let's look at one last example. So negative 10, absolute value, 2r minus 1 less than or equal to negative 60. Now, let's say I forgot to isolate first. Okay, let's just say for whatever reason, I'm having a bad day. I don't feel like isolating first. I'm just going to look at this and say it's an and. Okay, now here's why that's not true. We need to isolate the absolute value, so let's go back and actually do it now. So that means this negative 10 has to move, so I'm going to divide to get rid of negative 10. Now, do we remember what happens when you divide on both sides by a negative when you have an absolute or an inequality? This actually flips. So this actually, once you isolate the absolute value, you can see that this is an or inequality. It is not an and inequality. So that's why you always have to isolate first. That's the biggest takeaway from this video, is isolate first, then make your decision about if it's an and inequality or an or inequality. So work through some of these. Also, like I said, if you haven't seen the absolute value equations video, go check that one out, because if you know how to do those, if you know how to do the equations, the inequalities are going to be way easier.